In this video, we are going to see how to handle a soil model in XGSLab software. So we have just set a 50 Hz frequency, and we have to notice that we have three different models available: uniform, multi-layer, and multi-zone. Let's start from uniform. In the uniform soil model, like all in the soil models, we have two ways to set the soil model. First of all, set it, and in the uniform soil model it is very easy because we just have to set one value. So with the setting of 150 ohm meters, we have a soil model that is already prepared to handle a calculation. Going on, we have that the other option about the setting of the model is to calculate it from some or soil resistivity measurements. So to do that, we have to click on this button. We open this form in which we can arrange some soil resistivity measurements taken with the 4 pins method that is shown in this picture, in which we can see the measurement circuit that we have to adopt in that measurements. We are speaking about the banner method if this distance A is equal to the distances C. We are speaking about the Schlumberger method if A is different from C. So we have two ways to set the soil resistivity measurements. The first one is write them down. So we are going to see how we can do so. Simply dialing, obviously. We are entering the resistance because the measurement type set is R here. So we can go on to and go and so on. After having set all these measurements, we can run a calculation that is an average and nothing else. So we have this value that is a simple average of these ones, and we can apply it. And in this way, we have calculated the soil model. We can delete these values. Now we are going to see the last detail about the uniform soil model, that is a piece of a detail that is valid also for the multi-layer soil model. If we want to add a soil covering layer, we have this part of the panel that is the one where to do that. Let's go on now with the multi-layer soil model. We have to select it. Also in this case we have a double way to set it. First of all, setting it manually by setting the layers value. Obviously you have set all the layers, you have to confirm this, and when you confirm, the software also forces to infinite the thickness of the bottom layer. It's an obvious action. And you can also see the soil model in this way. The other way, that is the most interesting one, to find the multi-layer soil model is starting from the soil resistivity measurements. So also in this case we have to click on calculate, and we have this dialog box. We have some measurements in a Excel file. Consider that this was the original format. We have colored in different ways the different traverses. We have arranged these measures into this other table according to one column for tag that we have used to identify the traverse, other columns for A, C, and row. So going back to the software, we can check the measure type row. We can go back to Excel, copy, get back to software. Let's have a look before pasting on this hint. So paste tag A, C, and row. That is exactly the format that we have arranged in that table that we have copied. So here we have the complete set of the data we have copied, already set, and displayed here the different measurements. Using the tags, we can view one by one the traverses, and now we can calculate the soil model. We can let the software do the job by flagging this automatic detection, and we can let the software calculate. As you can see, this progress bar runs multiple times. This is because the software is making more trials in order to understand when this root mean square error goes to the minimum reasonable value, let's say. And we have that this is the result about the soil model that we can apply. And we can also see both in logarithmic and in linear scale. If we go back to this dialog box, we can see many other details. Obviously, we can uncheck the automatic detection and decide on our own which is the number of the layer we want to try. So we can have a final soil model that is the multi-zone soil model. We can first of all delete all these measurements, and we can try to select the multi-zone soil model. We have that this soil model can be set, like in the previous cases, adding one by one all the zones. The additional piece of information we have to set is the location where the zone landmark is located. So we should set the coordinates, or we, after applying these zones, that obviously now are not good because they are coincident, we can use this place landmark in order to set the landmarks graphically. Also in this case, we have the chance to set, to find the zones by calculating the soil model from some measured values. So also in this case, we have a real case measurement set that we can copy. Let's go back to the software, let's click on calculate and paste. Once we have pasted, we can calculate, and for each zone we have a uniform soil model.